Okay, we are starting a new unit on surface area and volume. Before we can get into 3D shapes, we have to make sure you have some basic knowledge of some 2D shapes. So, we're going to review 2D shapes to start off this chapter. So, this is going to be area, perimeter, and circumference. That's what we do with two-dimensional shapes. So, just a reminder, here's some shapes that you have seen in the past. The area of a parallelogram equals base times height. And how you determine what the base and height is of a parallelogram, there should be a line that is perpendicular to another side where the height meets the base. Now the height could be shown on the outside of the parallelogram, like if they could extend this line here and extend this line here to create this right triangle, which you would then say this is the height, and from here to here is still considered the base, even if they had to draw the height on the outside of the parallelogram. Okay, triangle is very similar, only it's like half of a parallelogram, so area equals half base times height. Again, we use this formula if we know where the height is in the triangle. Height and base meet at 90 degrees, so this would be considered our base. That dashed line in there would be considered your height. So again, the height is always wherever the right angle meets another side, height and base. Here's the thing, on a right triangle, if this is a right triangle, this could be considered your base, and this could be considered your height. Again, it's where the 90-degree corner is, so in this case the height's like an edge of the triangle, not just inside the triangle. Circle, we just did a whole chapter on circles, so hopefully you know this by now. The area formula of circle is pi r squared, and we are talking about the radius of the circle. Remember the radius? Let's see. Kite or rhombus? Okay, I'll move that over. Pi r squared. A kite or a rhombus is something we actually didn't do much in our quadrilateral chapter, but you create these lines that connect opposite angles, and those are called the diagonals, which we did do diagonals. We did do rhombus. So you have diagonals in this shape, and the diagonals are perpendicular, one of the key features of a rhombus. So the area formula for a rhombus is it's 1/2 d1 times d2, and the d stands for diagonals. So it's 1/2 and you multiply the diagonals. A trapezoid. In a trapezoid we have our parallel sides, those are called your bases. So you could say that's base 1 and this is base 2. We have two bases in a trapezoid, and then you have the height. Again, no matter what type of picture we look at, the height is where the 90-degree corner is. So we're going to say for a trapezoid formula, area equals 1/2 the height times base 1 plus base 2. Okay. I don't have it on here, but rectangle is length times width. Some people also use square. It's like a rectangle. You could say base times height. You could say length times width. Sometimes for the area of a square, they say the side squared, because like the sides are the same length. The other thing I want to put up, perimeter is adding up all the sides. Well, in a circle, we don't add up sides because they don't actually have sides. So by this circle here, we're going to put circumference is 2 pi r, or if you prefer the pi times diameter, either one of those are fine. So on the line here that says perimeter, we're going to say add up all the exterior sides. Alright, so that's just some review of some area formulas you may have learned in middle school. Now we're going to talk about composite figures. So we're taking it to a next level with some of our geometry skills. This time we're going to do composite figures. Is a figure that can be separated into regions or shapes that are basic plane figures, like triangles, parallelograms, trapezoids, rectangles, circles. So we can take an object and break it up into these different shapes, which is why we have all those different formulas. To find the area of a composite figure, you divide up the regions. So you're going to draw some extra lines in your picture to divide up the regions and find each area. Then find the sum of the areas. So basically you're going to take a picture, draw some lines in it to create shapes that we know the area formula for, and find the areas and then add them all up. Alright, on this one, the area, some things usually take a little bit of extra work, but if we're going to do the area formula, you have to decide what shapes can we use from here. And I would suggest the top shape is a trapezoid, and the bottom shape would be like a rectangle. So I need to find the area of those two shapes and then add them together. So the trapezoid formula is 1/2 the height times base 1 plus base 2. So sometimes it's helpful to go ahead and add in, like, okay, the height would be, let's say here. If from here to here is 12, this to this is 12, and the whole length is 18, that makes the height of the trapezoid 6. So let's do our trapezoid formula. Area equals 1/2 6 times, and then you add your bases. Well, base 1 is 15, and base 2 is the same as this one, so that's 23. And you can type all that in, you can add those first, and then multiply it all together. So 1/2 times 6, and then I'm just going to put times in parentheses, 15 plus 23, and you get 114. So that's the trapezoid part. The rectangle part is length times width, so we're going to do 12 times 23, and you can do 23 times 12, it doesn't matter which way you write that one, and you get 276. So if you add those two together, total them up, total area equals 390 centimeters squared. Okay, so find a couple shapes, find the areas, add them together. Perimeter on this one is a little bit more tricky because it does show us that these are going to be congruent on the sides. But it doesn't tell us what that length is, so we're going to have to do some math. Okay? The reason I say that is if those are the same length, then these two triangles formed on each end have to be the same size. So we know between those two lines is 15. So if you take 23 minus 15, we have 8 left. So that tells me each end, if these are congruent, should be 4 on this end and 4 on that end. Well, I still don't have that diagonal length in order to find all the numbers that go around the outside of the picture. So you're going to use Pythagorean theorem to find that length. Let's say I do 4 squared plus 6 squared equals that diagonal line, we'll call it c squared. And that is 52. So we're going to square root this one and just get a decimal. The square root of 52 is about 7.2. So I'll put 7.2 on this side and 7.2 on this side. And we want to add up all our numbers to get the perimeter. So perimeter. And typically I would just add them, but for the sake of your notes I'm going to write it out. We'd have 7.2 plus 15 plus 7.2 plus plus 12 plus 23 plus 12. You want to make sure you hit every number on the outside of the picture. Don't do anything on the inside, just the outside, all around the outside. So, let's see, 7.2 plus 15 plus 7.2 plus 12 plus 23 plus 12. And I get a total of 76.4. Remember, perimeter would just be in centimeters, whereas area was centimeters squared. Alright, let's try the next one. So, first thing, decide, okay, what kind of shapes do we have here? I see a triangle and a semicircle. You can call it a semicircle, you can call it half of a circle. So I have half of a circle, and I have a triangle. So, if we're doing area, let's just write area there. So I don't have to write that A, but I need half a circle, so half times pi r squared. On this one, you notice they put the 16 directly in the middle of the picture, so they're telling you the whole length is 16 versus like just the radius. So I'm going to say the radius for this one would be 8. So I'm going to do 8 squared. I'm going to round that to about 100.5. Okay, our triangle formula is 1/2 base times height. So because this is a isosceles triangle, 17 and 17, if you draw a line directly down, that's going to create the height inside there. Well, guess what? Of course they didn't give us height. Man, okay, so the radius was 8. And we need to figure out h. I'll just put, we got to figure out the height in the triangle. Well, to do that, guess what? You got to use Pythagorean theorem. So let's say h squared plus 8 squared equals 17 squared. So I'm going to square those. Subtract the 64 to the other side. And then square root that number, which is 15. So the height in the triangle is 15. So now I have enough information to, an area triangle is 1/2 base times height. So we'll say the base of that triangle is 16, and the height of that triangle was 15. Equals 120. So we're going to add our two shapes together. So we get 220.5, and that would be, this is meters, so we'll say meters squared. Perimeter means you add up all the outside. Guess what? In this case, we have a curved part. So to find the length from here to here, we need to use circumference. So circumference equals 2 pi r. So that would be 16 pi, or you can go ahead and figure that out. It's about 50.3, and I'm going to divide this by 2 because we want half of the circle. So we'll say that equals about 25.1. So now for perimeter, I'm going to take that 25.1 is the curved part, plus 17 plus 17 represents the two other sides you see in our picture. So you get about 59.1, and that would be meters. So we have our area equals this, and our perimeter equals that. Now I have to tell you, when we get into like surface area and things like that, even some these kind of problems, composite shapes, it's very, very important to show your work so I know, okay, this was like your circle answer, this was your triangle answer, and then this is like your total answer. So it's very important when you're doing this unit to organize your work so that I can tell what's going on. I use C for circumference, P for perimeter. Things like that really help us know what you're thinking and your thought process while you're doing this. Now this is the first one they gave you. They didn't actually draw any lines. So you have to decide, okay, what kind of shapes do you think you would see? So I would just take this and extend it and say I have a triangle and a rectangle. And I'm going to write the word area here. This is going to be my area of my triangle, and then the area of the rectangle. Triangle is half base times height. Well, on this one, it says the bottom here is 8. This is 1, and this is 2. So 8 minus 3 means this part here is 5. So it's not exactly drawn to scale, but because this is the 90-degree angle here, we know that this is the base and the 5 is the height. The rectangle we have is length times width, so I'm going to say 8 times 5, which is 40. Then we'll add those two things together. So 52.5 centimeters squared is our area of those two objects added together. The next thing we have is our perimeter. Well, I can say this side is 5, so this side over here should be 5. And I can see everything except for this diagonal. We don't have that diagonal. So again, to find a diagonal of a right triangle, you're going to have to use Pythagorean theorem. So we have 5 squared plus 5 squared equals c squared to get that diagonal. So I want to square root 50, which is about 7.1. And now I have enough information to find all the sides and add it all up. So perimeter, I'm just going to start up here. I'll say 5 plus 7.1 plus 2 plus 5 plus 8 plus 5 plus 1 equals about 33.1. So again, we don't add this 5 because it's not on the exterior. It has to be on the outside to add it up in the perimeter. Alright, so those are composite figures. Now we're going to do some word problems. We're going to take like area questions or perimeter questions and work backwards. Given a triangle has an area of 23 inches squared and a height of 5.1, find the measure of the base. So they tell us we're looking at a triangle. So the triangle formula is 1/2 base times height. And let's plug in the numbers that they gave us. They told us the area is 23, so that replaces your A. We don't know the base, so I'm just going to write B. But we do know the height is times 5.1. So, you can do this a couple different ways. To get rid of the half, you could times 2 to the other side, or you could just take half of 5.1. If I wanted to take 5.1, half of that, if you want to combine things on this side, we would have 23 equals 2.55b, because all these things are being multiplied together. And then to get b by itself, now you just divide both sides by 2.55. 23 divided by comes out to about 9. I have 9.02. So if you wanted to say that's about 9, that would work also. This time, you have to imagine they're giving you a square. The thing to know about a square is all the sides are equal. We know the perimeter equals 400. We don't know what each side is. So if you added up all those sides, x plus x plus x. Oh wait, never mind. Find the perimeter. The square with an area of 400. So we have an area of 400. So we wrote at the top of our notes that area equals the side squared. So if you note 400 equals the side squared, we can figure out how much each side is. So the side length is 20. Okay, use that now to find the perimeter. So 20 times, we have 4 sides, our perimeter would be 80. Okay, so I set what they gave me equal to the area formula and solved. Alright, the last one we have a word problem, and it's a trapezoid. We have a trapezoid, so I'll just draw a general trapezoid. It has an area of 29.5, we have a height of 5, and one base is 8. Find the length of the other base. I have no idea if 8's the top or the bottom. Okay, so we just know one of them is going to equal 8. So the area formula for the trapezoid is 1/2 the height times base 1 plus base 2. So let's fill in the information that they've given us. We have 29.5 is the area. They told us it has a height of 5. And we know one base, but we don't know the other base. So it said b plus 8. I know one base, I don't know the other base. So what I did is I decided to take half of 5. And to be honest, I really didn't want to distribute 2.5, so you can distribute it, which is totally fine. Not a bad number to distribute. But I just divided it to the other side to get rid of it. So 29.5 divided by 2.5 equals 11.8. Okay, so now the last step to get the base by itself, you subtract 8 over. Should equal, the missing base is 3.8. And that would be in yards. So sometimes they give you an answer like the area, and you have to work backwards to solve for like a missing side length.